In our first example, we have Melvin used integer chips to model and solve a problem. Which equation did he model? In the bottom right, we have several questions. I've written these questions so that you guys know what kind of question you need to think of when seeing problems like this. If you want, you can pause the video to write these questions down. Now, the question here is asking for us to find the equation that Melvin modeled. The first step in this is we need to count how many positive chips did we start with. So let's count the positive chips. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positive chips. Now, we are going to count our negative chips. We have 1, 2, 3, 4, 5, 6 negatives. So I'm going to write in parentheses 6. I'm going to write 6 negatives. And with these two, I know that I am going to add the 2. Now y'all are probably going to ask, how do you know that you're adding my positive and my negative chips? Well, if you look here, we've made 6 zero pairs because we have our positive and we've added our negative integer chips to the positive to make a 0 pair. So, based on our positive 12 integer, we know that A and B are out of the picture. And if we look at C and D, we have 12 minus 6, which we know is not negative 22. It should be 6, positive 6. And so D is our correct answer. In our next example, we have Kesha drew the diagram below. Which expression reflects the representation? So we have a keyword, expression. In the previous question, we were asked which equation. Now the difference between an equation and an expression is that an equation has an equal sign as well as its solution. And if you look at this question, A, B, C, D, none of them have an equal sign and the solution to that problem. Therefore, it is called an expression. So for this question, we have a different model. In this model, we have the number line and an arrow. Now, if you look here, the starting point of the arrow is on this end right here. The reason why I know that is because the direction that the arrow goes, it starts on one end and it ends where the point is. So to solve this, we are going to first write our starting point. Our starting point is between 10 and 20, and we have 5 tick marks, which is 2 increments. So we have 10, 12, 14, 16. So our starting point is safe to say is positive 16. Now, our sign, whether we're adding or subtracting, is going to depend on the direction of the arrow. So we see that the arrow is going to the left. So since it's going to the left, we are going to be subtracting. Now, you might be asking how much are we subtracting? So then we need to count here. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we are subtracting 24 . And wherever we end at, right here is going to represent our solution, which is -8. So let's write this down real quick. The first number represents the starting point. Write this down in your notebook. And this operation is based on the direction of the arrow. So if it goes to the right, we know we will be adding. If it goes to the left, we know we are subtracting. And then lastly, the second number right here represents the number of times moved. So we've moved 24 spaces to the left. So we know the answer is D as in dog. We can automatically omit B and C because we did not start at -16. -16 would have been right here. Which is not the case for us. Now this is the last example that I will be doing with you guys. And the rest y'all will do on your own. So here we have, Luann is playing a math game. She chooses 3 cards. The value of each of her cards is shown. What is the sum of the values of Luann's 3 cards? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. So here we have 3 cards, and based on the 3 cards, we need to find the sum, which we know that we are going to be adding. So a great strategy that I always teach my kids is to draw a chart or a table. And on the left side, I write my negatives. I write my negative integers. And on the right side, I write my positive integers. So here we have our first card, we have -12. Our second card, we have +3. And our third card, we have -5. Now, based on that song or that video that we saw, we know that same signs add. So we have all our negatives together right here. So I know that I will be adding all my negatives. 12 plus 5 is 17. Same sign, keep the sign. So I'm going to bring down my negative sign. And also I'm going to bring down the 3, since that's the only positive integers that we have. Now I have one negative number and one positive number. So we need to think back to the song. Different signs subtract, right? Same signs add, different signs subtract. So we have 1 negative, 1 positive, so we need to subtract 17 minus 3, which will give us 14. Second part of the song is different, keep the larger. So we have more negative actually. So we know that right here our difference is going to be negative 14. 17 minus 3 will give us negative 14. So now we have to bubble it. Now in middle school, y'all are dealing with negative integers as well. So it's important for us to label on our Scantron that we have negative integer. We're going to write 14 wholes. And just to practice, let's always write down to our hundredths value. So we have 14 with 0 tens and 0 hundredths.